Today we're taking a look at some sample problems on section 6-5 dealing with the central limit theorem, and we will begin in the book on page 292, and we'll start with number 2. And it says small sample. Heights of adult females are normally distributed. Samples of heights of adult females, each of size n equals 3, are randomly collected and the sample means are found. Is it correct to conclude that the sample means cannot be treated as normal distribution because the sample size is too small? And explain. Okay, as we look at this, because the original population of heights of adult females is that distribution is normal, then we don't need to have a sample of a large size. Size n will work when the original population is normally distributed. So the size n equal to 3 is not too small in the case of a population's normally distributed. So that is not a problem since the original population has a normal distribution. Okay, let's go down to number 4. In each drawing for the Texas 3 lottery, 3 digits between 0 and 9 inclusive are randomly selected. What is the distribution of the selected digits? If the mean is calculated for each drawing, can the distribution of the sample means be treated as a normal distribution? Okay, what is the distribution of the selected digits? Well, it's going to be a uniform distribution because each of the numbers from 0 through 9 are equally likely to be selected. So with a uniform distribution, if the mean is calculated for each drawing, can the distribution of the sample means be treated as a normal distribution? Well, the pick 3, your n is 3. So it cannot be treated as a normal distribution. With a uniform distribution, we need n to be greater than 30. Since the original distribution is not normal, it's uniform, we need n to be greater than 30. In number 2, because the original distribution was normal, we didn't have to be concerned about the size of n. So those are the 2 things we want to remember. Okay, so in our exercises 5 through 10, I'm going to do 6 and 10. Use the information about overhead reach of adult females. Mu is 205.5 centimeters. Sigma is 8.6 centimeters. The overhead reach distances are normally distributed. So normal distribution. And the overhead reaches are used in planning assembly workstations. Okay, so for number 6, if one adult female is randomly selected, find the probability that her overhead reach is less than 196.9. Okay, 205.5. 196.9. Okay, so in part A, we're talking about one female, so Z would be 196.9 minus 205.5 divided by 8.6. Okay, it's 196.9 minus 205.5 equals, divided by 8.6, and I get negative 1.00. So if I look up negative 1.00, negative 1.00, I get 0.1587. Part A. Probability that x is less than 196.9 is 0.1587. Okay, I'm going to use the same picture. So I'm just going to erase what I put there for part A. This time we're using X bar. Okay, in part B, if these females are randomly selected, find the probability that they have a mean overhead less than 205 centimeters. Okay. So I do need a new picture. Make that go back to X. Okay, so this time our D is 205 minus 205.5 times the square root of 36 over 8.6. So that's negative 0.5 times 6 and divide that by 8.6. Get negative 0.35. Okay, so negative 0.35 is 0.632. So that's our answer to A and to B. And it's a normal distribution. Alright, if one adult female is randomly selected in number 10, find the probability that her overhead reaches between 180 and 200. So we need to find the two and subtract them. So probability, this is part A, that x is between 180 and 200. Okay, so Z for 200 okay, negative 0.5 divided by 8.6 is negative 0.066.